Alright, here we have the PHET simulator for electric fields, and I can turn those on and off if I like, but for now I'm going to leave them off. Here is a little gauge that I had not really shown you previously, but here it is, and it, as the name implies, tells us the electric potential in volts. And so one of the things I can do with this to help hopefully elucidate what this electric potential does is I can mark off different voltages. And so I'm going to mark them off starting at about 100. And I'm going to do that for every increment of 10 until I get down to 0. And to save you time, I'm going to do one of those things where they do in cooking shows, where they show you the initial state and then they show you the end state. So let me just get something around 100 to start us off. Nope. Close enough. And now I'm going to take us all the way down to 10. So I'm almost finished. I just did 40 and now I can do 30. And one of the things that you can see is that the space between them, as I drop down, gets bigger and bigger every time. So getting down to 10 is going to require that I actually get pretty far away, just around to the edge of the screen. So up in here, this was 100, and then 90, 80, 70, and so on. And to prove it, I can pull this in here and put it in the middle of the crosshairs. So right around 100 there, and then we get down to 90 or so, and then 80, and then 70 is there, 60, 50, and so on. Right, so I have this, and I just use the plot button, and you can do this yourself. Obviously, as I go inside, if I try to raise up by 10, you can see it raises very, very rapidly as I get closer and closer to the center of the charges. So these are giving me what's called equipotential lines. They're lines along which the potential is the same. So if I go right here, I have about 19, actually about 20, right? And if I go over to this side, I've got about 20, and if I go up here, I've got about 20, and so on. So everywhere along these lines, there's the same electric potential. Now, if I throw in the electric fields, one of the things that you should hopefully be able to see here is that the electric fields are generally always perpendicular to the equipotential lines. And this has a very significant physical quality to it, namely that if we think of these equipotential lines as contour lines, which is how I've been teaching you to think of them, then the electric field lines point down. They point in the direction of the steepest descent for that particular electric field. Or for that, I should say, for that particular landscape created by these charges here. So these charges are creating this landscape, in this case a very steep mountain near them, and then it gets more and more gradual as you go off to the sides, and these contour lines are just representing that. And these electric field lines are showing us down. Now, one question that I have for you is, what happens if I take a charge and I put it, say, here, some sort of a positive test charge. So I put it here, and I move it sort of like that, so along that type of a path. How much work was done in order to make that happen?